which we use to solve the problem. It is the work energy theorem. The change in the energy is a measure of the work done by the external force. Another problem. A girl swings back and forth on a swing 4 meters long. The maximum height she reaches is 2 meters above the ground. At the lowest point of the swing, she is 0.5 meters above the ground. What is the girl's maximum speed and where does she attain it? Now picture this problem, a swing going back and forth. Now this is the ground and here is the girl on the swing. And we will consider first one extreme position where she is at the left extreme, at the maximum height. That is where she is now. At the maximum height, the velocity will be 0. Is that right? The swing comes to a maximum height where it stops and then it goes back. You notice that what happens here is the swing is taken to a height. It has potential energy. When you leave it, the potential energy changes to kinetic energy, and that kinetic energy changes to potential energy, and the oscillations of the swing is simply the change in energy from kinetic to potential, well, potential to kinetic to potential to kinetic, and so on. So at the maximum height at the left extreme, the velocity is 0 and the height is 2 meters. It says at the maximum height she reaches 2 meters above the ground. Now what is the energy that she has here? Because she is at a height h from the ground, at a height 2 meters from the ground, she has potential energy. What is the potential energy? U1 equal to mgh1. What is the mass? Well, we don't know the mass, so we're going to leave it as m. G is 9.8, h1 is 2 meters, so 9.8 times 2 is 19.6 times m. The potential energy at this height is 19.6 m joules. What is the kinetic energy at this position? Kinetic energy equal to 0. So we say at this position K1 equal to 0, U1 equal to 19.6 m joules, where m is the mass of the girl. The total energy at the maximum height is K1 plus U1, that will be 19.6 m joules. Okay, what happens? This potential energy is now going to change to kinetic energy. She's going to fall back to the equilibrium position. The speed is maximum at the lowest point. You see, that is where all this potential energy, you can see, at this position when she is at the extreme, there is only potential energy here. When she reaches the lowest point, all that potential energy gets converted to kinetic energy. Now this is the case of the swing. If you notice, you pull it to one side, it has now potential energy, and because it has potential energy, when you leave it, it falls, and you can see the energy conversion. When it falls back to the lowest position, it has maximum speed, and because of the maximum speed, it climbs to the other extreme. You see, it cannot stop at the lowest extreme because in falling it has acquired a speed. So where does it have maximum speed? Maximum speed happens at the lowest point. there is no speed at the highest point. All the potential energy is converted to kinetic energy at the lowest point. Alright, let's use this to solve this problem now. The speed is maximum at the lowest point from the ground. So the swing is come now. This is the lowest point. The speed is maximum there. V equal to V max. And at the lowest point, H2 equal to 0.5 meter. So she is 0.5 meter above the ground at the lowest point. So this height is 0.5 meter. That means she has a certain amount of potential energy and a certain amount of kinetic energy at this point. If K2 is the kinetic energy there, that K2 will be 1/2 mv max squared. The velocity there, or the speed there, is the maximum speed, and I'm going to call it V max. So the kinetic energy K2 at the lowest point is 1/2 mv max squared. The potential energy at that point is mgh2, and that will be, what is mgh2? Now we don't know m, so we leave it like this. G is 9.8, h2 is 0.5 meter, so 9.8 times 0.5 is 4.9. So mgh2 is m times 9.8 times 0.5, that is 4.9 m joules. That is the total, that is the potential energy at that point. What is the total energy at the lowest point? There will be potential energy U2 plus the kinetic energy K2. That is 1/2 mv max squared plus 4.9 m. Alright, we now know the total potential energy at the highest point, and well, we now know the total energy at the highest point. What is the total energy at the highest point we calculated? I think it was 19.6 m. That was the total energy at the highest point. And the total energy at the lowest point is 1/2 mv max squared plus 4.9 m. Well, the total energy must be the same, is that right? Energy can change from one form to another. At any position of the swing, the total energy must be the same. Conservation of energy demands that K1 plus U1 equal to K2 plus U2. The total energy cannot change. It must be conserved. That means K1 plus U1 is 19.6 m joules. K2 plus U2 is this quantity, 1/2 mv max squared plus 4.9 m. Now look at the beauty of this equation. You see m appears in every term. You can divide by m throughout and that will disappear. That means the only unknown term is V max. We can now solve for it. So dividing by m and multiplying by 2. Well, multiplying by 2 will eliminate this 2 here. So what will you get? Dividing by m and multiplying by 2, this will become, what is that? 19.6 times 2 is 39.2. Multiplying this term by 2 and dividing by m, m will go, 2 will also go. That will be only V max squared left there. And dividing by m and multiplying by 2, this will become 9.8. 39.2 equal to V max squared plus 9.8. Solve for V max squared. V max squared is 39.2 minus 9.8, that is 29.4 meter per second squared. Therefore, V max is square root of that, 5.4 meter per second. You see, the neat way to solve problems using the conservation